Welcome to Supercomputing 2022 in Dallas. I'm here at the Swiss booth with our guest Nils Wedi from the ECMWF. He's an invited speaker at the Supercomputing 22. So thank you for your time and welcome. Nils, so you have been collaborating with Switzerland for very long, but now we are talking in this supercomputing. We have talked a lot about the future. Where are we going? In which direction we are moving? How do you see the collaboration, or how do you see a possible contribution of Switzerland in ECMWF?
So obviously, Switzerland is a member state of ECMWF, so we are very keen to continue technological partnerships with Meteo Swiss in particular, of course, who is representing Switzerland at ECMWF, because they have a lot of great ideas in terms of, for example, the DSL developments. We have a local project, a Kilos project in Switzerland, where we are closely collaborating with the development of domain-specific languages for dynamical cores and weather and climate. And we also want to participate with Switzerland in connecting Alps and the vision of Alps being a software-defined supercomputer and a computer that combines the machine learning pipelines with the kind of weather information that ECMWF is providing. So we are hoping to make a very close link between the information source and the technologies that allow to exploit these weather information.
You have, in your talk, you have been saying that we have to prepare ourselves for the data deluge. So how do we prepare? I mean, how do we center ECMWF prepare for this data deluge?
So our development chef, Tiago Quintino, has all the answers, of course, as I mentioned on the slide. But really, we have a whole stack of digital twin engine components that we are developing as part of Destination Earth that are going to help with this data deluge, are going to help with the gradual reduction of information that's coming right out from digital twin engine, that's coming right out also from our operations at ECMWF in terms of numerical weather prediction. And we're using these components in order to make access to this data easier, to make compression of this data easier, to make to basically also set standards that would allow really to connect to these outflowing large component information, because it's clear we cannot archive. We cannot archive all this data, so we have to find a way to asymptotically reduce towards what's kind of still acceptable and affordable, and then bring this to the user.
And of course, the part of the thing that we want to understand is the climate change and now is affecting the planet. So do you foresee the need of all the various research infrastructure being part of this effort for the climate? Switzerland, Europe, United States, do we need a collaboration that goes beyond borders?
Yeah, I think definitely we need a collaboration to be able to define these standards. You know, there are also private companies involved. They have like their own ways of trying to feed artificial intelligence, data pipelines. They come from an environment where they use this or have like successfully deployed this in the context of, driverless cars, for example, and things like this. So we are collaborating, for example, here also with NVIDIA. And we would like to really make sure that we can define interfaces that are usable by people that we haven't directly interacted with, that are more like automatic basically in the future. And that's clearly across borders. Yeah.
So thank you very much, Neil. So you have collaborating with Switzerland for very long, also on ICON. We have seen you on Pitzstein, so we hope to see you also on Alps on the next infrastructure.
We are very grateful for the discretionary allocation you gave us on Pitzstein, and we hope the similar thing will happen on Alps. Thank you very much.
Thank you for your time.